Hello everyone, I am Yasuhiro Takeuchi and I'm responsible for development operation support system at NTT Docomo. I'm from Japan. I'm so happy to come here. So today, I'd like to talk about NFV in NTT Docomo and a plan of next generation OSS. We have the plan to maximize the value of NFV using our next generation OSS. We call it Smart OPS. So firstly, let me introduce our company NTT Docomo. NTT Docomo is a part of NTT Group. So NTT Communications made presentation yesterday. We are same group. NTT Docomo is the largest mobile phone operator in Japan with nearly 50% market share. And we were among the first telecom carriers in the world to introduce services like 3G and 4G. And we have announced plans to introduce 5G services in 2020. So this is our company's vision. Docomo has started as a mobile communication company, offering a variety of services through mobile networks. Today, by working together with our partners from different business areas, Docomo is aiming to become plus D co-creation company, so providing new added value to the customers. Well, today I'd like to talk about our operation support system and share our roadmap to future. So firstly, I'll talk about evolution of the network virtualization. So Docomo has implemented VEPC with the aim of reducing the TCO and increasing the network reliability. So we have rolled out commercial VEPC on March 9, 2016. We became the first carriers in the world to have done multi-vendor environment. So this is a commercial network configuration of VEPC. So VEPC is installed into the legacy EPC pool. This pool covers Japanese largest city, Tokyo. The contents of the services are exactly the same as the existing EPC, including LTE and LTE Advanced and Voice over LTE. We have achieved both goals. So this is a VEPC deployment architecture. So we use OpenStack as Vim, and we asked Cisco to supply us the SDN, and they have contributed in a great way. Okay, there are two types of OPEX, NFVI OPEX and VNF OPEX. So as for NFVI OPEX, special skills are needed for each dedicated hardware types. But now that hardware can be unified, maintenance optimization takes place. But VNF OPEX currently hasn't changed. It will decrease with OSS improvement. We will explain this next session. So second graph is agility of service provisioning. Until now, in order to build new services, we have to build hardware. But with NFV, we can deploy quickly by only creating a Vim in a predefined resource pool. However, we are thinking about further improvement. We will also explain this in session 2. So then, as evolution of the operational side, I will explain Smart OPS, plan to maximize the value of virtualization. So this is the big picture of our Smart OPS plan. The legacy OPS is that the operator monitors the network devices and then control it. And the next OPS is that the service provisioning will make the operator tasks or process automatic. And furthermore, we'd like to automate the task of the operating thinking by the data analytics. That is the Docomo OPS aiming. We are aiming the advanced OPS. NSO is the important part of service provisioning in our OPS. We achieve better resource allocation, preserve and improve QoS, QoE, and rebuild service quicker by real-time analyzing big data from network. Okay, our smart OPS follow TM Forum Zoom project concept. So same as TM Forum Zoom project concept, our smart OPS adds business value on its NFV manner. And we are also joined the activities of ZSM. ZSM is Zero Touch Network and Service Management. So we are inputting requirements to this meeting. And we want to realize strong cooperation between operators and avoid fragmentation of OSS markets. So next, I'd like to talk about the service provisioning. It allows faster service delivery and cost reduction through automation of planning and designing and deployment. This is the functional architecture of service provisioning. So service provisioning is made up of auto designing unit and auto deployment unit. So NSO is used for automatic construction of network. So NSO is providing L3 switch, which is Nexus 7K, and SDN controller, which is SCI, configuration capability. So this slide explains result of our smart OPS. So Docomo has launched the commercial NFV in 2016, but still a lot of manual operation among multiple divisions is needed to build the NFV today. NFV construction requires a lot of preparation of the SDN, physical servers, and NFVs. For example, equipment estimation, configuration of network equipment, network testing, and more. The service provisioning is the solution for this challenge. Once its implementation is completed, we can deliver service. We can deliver services with one click, and the way achieve speed up and OpEx reduction at the same time. So based on our calculations, NFV itself shortens construction period by 25%. If we combine it with the service provisioning system, which including NSO, we can reduce this period by more than 80%. This is a 5 times improvement in speed. So we already implemented automation for network configuration by NSO. It reduced over 90% of OPEX at network tasks. So in service provisioning, I'd like to talk about the reason why did we succeed in the reduction of the operational cost. So before, Docomo operator configured several tens of thousands of parameters into ACI by manual. They configured each parameter from GUI. It took a few weeks to configure all parameters into ACI. That was a big issue for Docomo users. After service provisioning, NSO has loaded the spreadsheets and has configured these parameters into ACI. It takes less than 1 hour to configure all parameters into ACI. And so we succeeded in the reduction of the operational cost. And we also succeeded in the improvement of the quality. That means the configuration mistake is 0% by NSO. So this slide explains the data analytics. Let's take main 2 use cases. First use case is auto planning. With introduction of NFV, it becomes possible to increase BNFs on demand. That means that the real time becomes shorter for the servers from the resource pool. This helps to reduce the capital investments and leads to reduction of overall maintenance costs. So in data analytics, by making equipment planning and demand forecast real time and automate it using the AI. Second use case is fault sign detection and silent failure detection by AI. AI analyzes logs and traffics in real time and thus detects silent failure and failure sign fault signs in order to minimize QoS/QoE issues. We have already applied several forms of fault sign detection in daily operations. So in this phase, we plan to advance real-time analysis to detect more failure patterns. So we made a presentation of data analytics at TM Forum Digital Transformation World, which was held last month in Nice. So if you are interested in, please check out the DTW webpage. So finally, I will talk about the future plan. So Smart OPS, we explained in today's session. Focus for Docomo internal operation transformations. And in the future plan, I will talk about how OSS should evolve in the 5G and the IoT era in order for carrier networks to provide value to society. The keyword is the business model of B2B2X and end-to-end orchestration. So this slide explains the concept of E2EO. Smart OPS automates core network operation. Our future plan aims to expand to radio access network and transport area So we want to make it possible to orchestrate hybrid network end-to-end. We want to discuss this matter with Cisco team. So this is vision of B2B2X. To provide value to society in 5G and IoT era, so we think there is an important mission of OSS. It is to provide quality assurance and to quickly launch new services. So therefore, automation of service provisioning and NSO are much important. So in conclusion, we expect NSO and the Cisco team very much with both smart OPS and the future steps. So that's all for my presentation. Thank you. ありがとうございました。